Alright, so let's look at some more trigonometric integrals. This will be my sixth example. So, and we're going to be dealing with the tangent and secant. Well, in this problem, just the tangent. But here's some guidelines for tangent and secant. I'm not going to go through them. If you want to see a little explanation of this, then you can check out my trigonometric integrals example 4 video. That's where I kind of go over these. Alright, but in this problem we're going to be working with this third one. If there are no secant factors and the power of tangent is even and positive, convert a tangent squared factor to a secant squared factor. Okay, then expand and repeat if necessary. So basically, if this is an even number, then I'm gonna have a tangent squared factor I need to pull out, and then I'm gonna take this tangent squared factor here, and I'm gonna convert it into secant squared minus 1. Okay. Alright, so let's take a look at our example. Alright, so I've got tangent to the fourth x dx. Alright, so just like it says, I've got tangent squared x times tangent squared x dx. I'm going to pull out my tangent squared factor. Okay, and then I'm going to convert this in terms of secant. Alright, so you remember your trig identity. 1 plus tangent squared equals secant squared, and if I subtract 1 to both sides, that gives me tangent squared is equal to secant squared minus 1. And so that's what I'm going to do. This tangent squared here I'm going to replace with the secant squared x minus 1. Alright, so this is going to give me tangent squared x times secant squared x minus 1 dx. Okay, let me erase this. Alright, so now what I'm going to do is I'm going to distribute this tangent squared. So that's going to give me tangent squared x times secant squared x minus tangent squared x dx. Alright, now I'm going to split this integral up, and you can see that in this part here we can use u substitution, because if we let u equal tangent, then du is secant squared. Okay, so that takes care of that. Alright, so that's going to be tangent squared x secant squared x dx minus, and then here I have tangent squared x dx. Now, let's look at this tangent x. Well, there's really nothing I can do here. I can't let u equal tangent because if du is secant, and I don't have a secant term here. I don't know the antiderivative of tangent squared, but look at this. I can rewrite tangent squared as secant squared x minus 1. So that would give me a secant squared minus 1 here. Well, I know the antiderivative of secant squared is what? Tangent. And then the minus 1, what's the antiderivative of 1? It's just x. So I'm going to convert this into secant squared x minus 1. And so that's going to give me tangent squared x secant squared x dx minus, and then this I'm going to convert into secant squared x minus 1 dx. Alright, so let's see what we've got. I'm going to use U substitution on this one. Okay, so I'm going to let U equal tangent x, so that tells me du is equal to secant squared x dx. Alright, so this is going to give me, in the place of tangent, I'm going to put u, so that's going to be u squared, and then you can see here that secant squared x dx, secant squared x dx is du, so that's du minus, and then I can just go ahead and integrate this, and make sure you keep it in parentheses because it's minus the whole thing. Well, the antiderivative of secant squared is tangent minus, and then the antiderivative of 1 is x. Okay, and then all this is plus c. Alright, so now all I have left to do is to integrate this, so that's going to give me u to the third, and then times 1/3, minus, and I'm going to go ahead and distribute the minus, so minus tangent x plus my constant term c. Okay, and so now I've got to get this all back in terms of x, so in the place of u I'm going to put tangent x, and so this is going to be 1/3 tangent cubed x minus tangent x plus c, and this would be my final answer. Okay, so you can see that when we're doing these, basically all we're doing is we're rewriting these things so we can use u substitution. Okay, that's basically what we've been doing in all the videos, and then in this one, in this problem, see, I didn't know tangent squared, but I did know the antiderivative of secant squared, and I knew that I could take the tangent squared and rewrite it in terms of secant squared. Okay, so it's all about rewriting it into something that you know. One of the antiderivative rules that you know. Okay, all right, so I hope this video's helped. Hope you'll check out my other videos. Thanks.